Welcome back, everyone. In this video, we're going to work on two kind of commonly occurring classes of story problems, uh, uniform motion problems and mixture problems. We'll take up mixture problems first. In mixture problems, typically we're mixing something. Often it's coins or peanuts and candy or two different strengths of something like antifreeze or an alcohol solution or fruit punch or something. But basically we're mixing two things. Usually it's almost always two things, and there's two attributes to the two things. So in this first example, we'll have it's about quarters and nickels, a mix of quarters and nickels in Tammy's pocket. So one feature of the nickels and quarters is their value in dollars. A quarter is worth 25 cents and a nickel is worth 5 cents. So that's one quantity that's involved, the value in dollars. Another quantity that's involved is how many of each coin there are. So there's the number of nickels and number of quarters. There's the value of the money in nickels and the value of the money in quarters, and then also the total amount of money and total amount of coins. So there's two different kind of characteristics to the objects we're looking at in this problem. The number of each piece of metal, each coin that we have, and then also its value. So we'll have basically two kind of attributes within all of our mixture problems, as we'll see. So let's get started on this one problem. It says Tammy has $6.55 worth of quarters and nickels in her pocket. The number of nickels is 5 more than 2 times the number of quarters. How many nickels and how many quarters does Tammy have? So you can set this up using two variables and a system of equations. Our approach throughout this whole video is to do this using just one variable. Even though it's asking us for two different things, we're going to express that second thing that we're asked for in terms of that first variable. So this question is asking us how many nickels and how many quarters Tammy has. In this sentence, it's telling us the number of nickels in terms of the number of quarters. So I think using quarters for our variable is going to be the most easy to understand. Okay, often with word problems, it's a good idea to use a meaningful variable name, like N for nickels or Q for quarters. My Q's tend to look like 9s though, so I'm going to stick with X for this one. Okay, so X will be the number of quarters. Okay. So it's important, again, to make sure that you know what your variable stands for. Here, the X is standing for a number of quarters. If you had 3 quarters in your pocket, and that would be worth 75 cents, right? So if I asked you how many quarters you have, you wouldn't say 75 cents, right? The number of quarters you have is 3. Their value is 75 cents. What our variable is standing for here is the number of actual pieces of coin or pieces of metal, the coins we have, not the dollar amount. That's what our variable stands for. Okay, so if X is the number of quarters, then we can put down the number of nickels. The number of nickels is 5 more than 2 times the number of quarters. So 5 more than 2 times the number of quarters. That will be the number of nickels. Okay, so then that's defining the quantities in the problem in terms of the variable we have. And so let's see, the next thing we have is the total amount of money is $6.55. So that $6.55 is going to come from the money in quarters plus the money in nickels. Okay, so we're just going to add that up. So the $6.55, each quarter is worth 25 cents. So it'll be 0.25 times X. That's going to be how much money we have in quarters. And then nickels are 0.05, and our number of nickels is 5 plus 2X. Okay, so we have a value, 25 cents, times a number of coins, and then a value, 5 cents, times the number of coins. We add all that up and it should equal $6.55. One thing to be careful of is that a nickel is worth 0.05 here. Frequently when I grade students' work, they'll have 0.5 for that. That would be 50 cents, okay? 0.05, that's 5/100 or 5 cents. Okay, so it's not 0.5. Okay, so we want to be careful with that. So make sure that you're okay with the setup on these. Most often people have more difficulty with setup than actually solving the problems or solving the equation. So let's go ahead and solve it though. Keep in mind as we solve this, what we're looking for is a number of quarters. So we'd better get a whole number answer, right? We're not going to get 6.2 quarters, and we better also not get a negative number for an answer, right? If I get a fraction or a negative answer, then that means I've done something wrong. But let's try. So we have $6.55. Nothing to do here. We'll distribute this 0.05. This will give us 0.25 plus 0.10x. Okay, at this stage, you can either multiply by 100 to eliminate the decimals, or you could just keep them in. I think I will just keep them in for this. So I'm going to combine like terms. 0.25x plus 0.10x is 0.35x. And then we're going to subtract the 0.25 from both sides. So that's going to be 6.30 will be our 0.35x. And then we're going to divide both sides by 0.35. So 6.30 divided by 0.35. That will be our x. So let's see what that works out to be. 18. Okay, so what was that? Was it 8? Was that nickels or quarters? Fortunately, we wrote it down. X is the number of quarters. So we should have 18 quarters. And then the number of nickels is twice that plus 5. So 2 times 18 is 36. 36 plus 5 is 41. So it's 41 nickels. Okay, and I'll leave it to you to check that that works out. If you take the 18 quarters at 25 cents a piece and then 41 nickels at 5 cents a piece, that should all add up to the $6.55. Okay. All right, so that takes care of our first example, and a lot of the mixture problems have this kind of same basic format. We read and understood the problem. We set a variable to be one of the things we're looking for. The other thing we're looking for, we have an expression for that. What we're looking for is a count this time. It's how many coins of each value there are. Our equation was in terms of value. It was in terms of dollars here, not in terms of number of coins. We solved the equation using algebra, and then we can check and make sure that that makes sense. Okay, so let's move on to the next example. All right, so our next example is from a category of mixture problems called a ticket problem. And ticket and stamp problems are really similar. I've chosen to do a ticket problem instead of stamps because we just don't use stamps very much anymore, right? So tickets. So here it says, one day the museum sold 115 tickets and made $1,163. Adult tickets cost $12. Child tickets cost $5. How many of each type of ticket were sold? So on this one, it's different from the coin problem in that it's about tickets instead of coins. But what the similarities are is that there's 2 different types of thing. Last time it was coins. This time it's tickets. We have adult and child ones, where before we had quarters and nickels. Now, each of the 2 types of tickets have a value. Adult tickets are $12, child tickets are $5. So there's going to be a number of things here, how many of each type of ticket there are, and then also their value. The total amount of tickets was 115. Before we were told how many nickels there were in terms of how many quarters. We weren't told the total number of coins. Here we're told the total number of tickets, and we just happen to know that they're divided into adult and child. We know the total number of tickets. We know the total dollar amount. Based on this, we want to figure out how many of each kind of ticket there were. So whether you want to make the variable be how many how many adult tickets there were or child. It doesn't make any difference on this one because we're just given the total. I'm going to pick the child tickets, and I'm going to use C for this. This will be the number of child tickets. Okay, notice that that's not the money received for those tickets. It's how many little paper tickets or whatever were sold for the child tickets. Okay, there were 115 total tickets sold. So if we want the number of adult tickets, then that is going to be 115 minus C. Okay, 115 minus C plus C has to equal 115. That's the total number of tickets we have. Also, if you think about the total amount, here was 115 tickets. If some of them were, C of them were child tickets, then the rest of them, 115 minus C, have to be the adult tickets. The most common kind of mistake with this part is that people will put C minus 115, but that is incorrect. Okay, if you try that with a value for C, it's you're going to end up getting a negative number, and it is just incorrect. So here it's the total minus the amount of the first part, which is how many child tickets there are. In this case, it's C. Okay, so those are expressions for the amount or number of each type of ticket there are. Okay, so then our equation is going to be about the value again. So the $1,163 that the ticket office made were $5 for each of the child tickets. So that will be 5C. We're multiplying, right? If there were 3 tickets and they're $5 each, 5 times 3, $15. If C were 10, if there were 10 children's tickets at $5 a piece, 10 times 5 is 50. Here we just don't know how many tickets there are. There are C of them. So we'll have 5C for the dollars for the child tickets. For the adult tickets, they were $12 a piece, and we sold 115 minus C of them. Okay, so then that is the setup. Notice our equation here is about a dollar amount. It's not about a number of tickets. Okay, so again, make sure that you have the setup correctly and make sure that you understand it before we go through solving it. One other thing that you'll notice is that on this equation, we have on the right side a sum of 2 products, something times something plus something times something. And that is something that we had before with our coin problem, 0.25 times x plus 0.05 times 5 plus 2x. Something times something plus something times something equals something else. That is kind of a common feature for mixture problems, is you have that sum of 2 products kind of setup. Not always, but it's very often. Okay, all right, so then once we're satisfied with the setup, we can forget what the story is about and just do some algebra to solve this thing. So we'll have 1163 is 5C, and then we need 12 times 115, and that's 1,380. And that'll be minus 12C. All right, so now we're going to combine like terms. We'll have 1163 is equal to negative 7C plus 1380. We'll subtract the 1380 from both sides. And so don't be put off by the negative numbers in here. We have both sides with a negative value, so our C will end up being positive. I said it, wrote it, negative 217. Okay, all right, so then C will be negative 217 divided by negative 7. And that's 31. Okay, so it looks like 31 child tickets were sold. So if there were 31 child tickets, then there should be 115 minus 31, adult tickets, and that's 84. Okay. So then let's go ahead and check it out on this one and make sure that it works out. So we have 84 adult tickets that were $12 a piece. And we had 31 child tickets at $5 a piece. So the adult money is 84 times 12, or $1,008. And then 31 times 5 is 155. And then adding those two together, we get 1163, as we should. Okay, so that is the check to make sure that it works out. All right, so that takes us to the end of this ticket problem. In our next problem, we're mixing snacks. Sometimes we're blending fruit punch of varying strengths. Sometimes it's two different kinds of coffee, a good coffee and a cheap coffee. Here it's a snack mix, okay? So there's very similar setups to these problems, just different stories. Okay, so the story here, it says Dash is mixing nuts and cereal squares to make a party mix. Nuts sell for $7 a pound and cereal squares sell for $4 a pound. If Dash wants to make 30 pounds of party mix, that's a lot of party mix, he wants to make the 30 pounds and that he can sell for $6.50 a pound. We want to know how many pounds of each ingredient he should use, how many pounds of nuts and how many pounds of party mix. Pounds of cereal squares, sorry. So the two unknowns here are the pounds of nuts and the pounds of cereal squares. So, and the other kind of attribute is, again, the dollar amount for these things. So for the variable here, I'm going to let N be the number of pounds of nuts. And then the pounds of cereal squares, I know that he wants to make 30 pounds total for the mix. And so 30 minus N will be the number of pounds of cereal squares. By the way, it's a good idea to get into the habit of writing the stuff that I just did, telling what each variable represents. I know it seems like extra work, but if it helps you get the right answer, it is worth it. So get in the habit of expressing what your variables stand for. Okay, so N is the number of pounds of nuts that Dash will use, and then 30 minus N is the number of pounds of cereal squares that Dash will use. Okay, and so the calculation then is going to be about the money that he's going to spend to make this mix. So the nuts sell for $7 a pound. So how much money is spent on nuts? It'll be $7 a pound times the number of pounds. Notice, by the way, that we're not done here, okay? Notice, by the way, that the units here have to match. It's $7 per pound, and we're multiplying that by N pounds. Okay, so the units there end up being dollars, okay? Dollars a pound times pounds will give you an answer that is in dollars. Okay, so we have 7N, that's the nut money, plus the cereal squares money. Those cost $4 a pound, and Dash will use 30 minus N pounds of the cereal squares. Okay, so that is the start. That is nut money plus cereal squares money has to equal what he's going to sell this mix for, which is $6.50 a pound times the 30 pounds. Okay, you want to be really careful about the setup for this, is because the units, like I said, need to match. The left side is in dollars. Dollars per pound times pounds will give you an answer in dollars. Dollars per pound times pounds, answer in dollars. So the left side is in dollars. The right side, if I just left off the 30, which is a really common mistake, and just wrote 650, this is dollars per pound. And it seems picky and stupid, but it totally makes sense if you think about it. Dollars is not the same as dollars per pound. Okay, 650 is dollars per pound. In order to get this right, we need to ensure that the units match. The $6.50 per pound needs to be multiplied by the 30 pounds so that the units on the left and right side are both in dollars. Like I said, the most common mistake in setting up a problem like this is leaving off that 30, but it does need to be there. Dollars a pound times pounds. Okay, again with the structure, you'll notice that we have a sum of two products, something times something plus something times something, whereas before we just had a single number on the right side. Now we have a product again on the right side, but our answer or our equation is in left and right side are in dollars. Okay, so again, once we have the setup done, we can go through the mechanics of solving the problem. So let's do that. We're solving the equation. So we're going to begin by distributing to remove the parentheses. 4 times 30 is 120. And then 650 times 3, that's 1950. So 195. Okay. All right. So then we're going to combine like terms. So we'll have 3n plus 120 is 195. 3n is 75. And so n looks like it is 25. Okay, so it looks like he's going to use 25 pounds of nuts. And he's going to use then 5 pounds cereal squares. Okay, and then we can just check and make sure that that works out nicely. So let's verify that with the money. The nuts are $7 a pound. So 7 times 25 is going to be 175. So he'll spend $175 on nuts. That's a lot. And then the 5 pound cereal squares, those sell for $4 a pound. And so that's 20. So $20 on cereal squares. So he's going to spend in all $195. And so we need to make sure that that is the same as the 30 times 650. He's going to sell all 30 pounds for $6.50 a pound. And then 30 times 650 is 195, which is what we need. Of course, realistically, he's not going to sell the mix for exactly what he bought it for because he's not making any profit for it, but this is how the problem goes. All right, so that takes us to the end of this video. We've seen some examples of working on mixture problems. When we move on, we'll take a look at some uniform motion problems. In the meantime, let me know if you have any questions and have a great day.